So we've seen our array-based approach. Let's take a look at the node-based approach next. And in this approach, we're using the same node that we had for our stack-based approach. So we still have a node, it has a value and a next, right? A pointer to the next value in the sequence. And using this idea, we can make our queue a bit more efficient compared to the array-based approach. So in our initialization, we're going to keep track of really two different things here. The two different things that we're going to keep track of is the front of the queue, which starts off as none, and the rear of the queue, which also starts off as none. We'll also keep track of the size, so actually three things that we'll keep track of, just to have the size is helpful for us for our various operations. So now when we do our onQueue operation, we're going to see that it follows a bit similar to the stack, but the actual method of updating our values is going to differ since we're using first in, first out in this case. So we start by creating a new node, as we've done in previous examples. So we create a node based on the value, and its pointer is going to be none at this point. And what we're going to do is we're going to take a look at the size of the queue. And the reason that we're doing that is because, so if the size is equal to 0, so there's nothing on the queue currently, the front and rear would be the same thing, just a single node that's been inserted. So in that situation, we would just have self.front equals self.rear equals new node. But if there is something on the queue already, then we just need to update the end of the queue. So basically what happens is the value that we're inserting will then point to the current end, and then the end gets updated to be the value that we're inserting. So what that looks like is we do self.rear.next equals our new node, and then the self.rear equals our new node. So you see all we're really doing is we're just updating it so that the rear is now pointing to the node that we've inserted, which effectively places it at the actual end of the queue itself, right? So that's generally what this is doing in terms of sequence. So if we were taking a look at this, say, from the example of, maybe we had 1 and 2 in our queue before. If we were to go and insert the 3, what happens is 2, the current rear gets updated to point to 3, and then the rear just points to 3. So 3 becomes the new end of the queue. So that's the way that that's generally working for us. We see all of this is really just memory operations, so this is about a constant time-based operation for our queue. Now dequeue is basically going to use the following idea. First, we're going to, of course, check to see if the actual size of the queue is greater than 0, right? So if there's actually something to remove from the queue, so self.size is greater than 0. If it is, we are going to basically return the value of the front, and then we're going to actually remove the front from the queue. So what we do is we first start by storing the value that's at the front, so self.front.value. And then what we do is we do self.front equals self.front.next, and then self.size minus equals 1, just like that. And then basically the else here is going to be to raise an exception for a queue underflow. And I just noticed that I forgot to place the return here. We, of course, return the value back as a result. And just one other adjustment here, I realized inside of my onQueue, I just forgot to increment the size. So let's make sure to do that as well. That way we ensure that, of course, the size increments when we add things and decrements when we remove things, right? So that gives us these two operations. The final one that we have is our peek operation, which is a very simple one to do. Basically, all we do is we just say if self.size is greater than 0, we return self.front.value. Otherwise, we raise an exception that we have a queue underflow. And there you go. That's all that's really required for our queue. So you see that generally each of these are going to be O1 since they don't involve any sort of actual changes based on the size of the inputs. No matter what the input size is, we're just adjusting some memory locations. So generally we have a full constant time implementation. And really the implementation is very similar to the stack, right? Like aside from the idea that we now have a front and rear, basically the operations are looking about the same. This removal looks really similar, just in the stack this was top instead of front. This right here is a little bit different, but it's really not that complicated, right? It's just like a few additional lines or changes for it, right? And then peek remained basically the same, just again, front instead of top, right? So it's not too complicated of an implementation, and that gives us a new way of being able to access and work with data. As a final finish up here, let's just go ahead and try out some of our operations to make sure that they're working. So like I did before, I'm going to onqueue some values. And then all we're going to do is we're just going to test some different operations. So I'm going to print q.dequeue. And then what I'm going to do is I'm going to print out a peak, and then we'll do some more dequeues. So we'll do a peak here, and then we'll do some dequeues after. Okay, so let's give that a try and see what ends up happening with this. You'll see that the dequeue gives us 1, which was the first thing inserted, and then we get 2 as our peak since that's the new front. We remove it, and then 3 becomes our new front, which then gets removed. So we see that this does seem to work pretty well. Everything's in constant time, so we're all happy with this implementation. So thanks so much for watching this video. I'll see you in the next one.